Hello students, welcome to EPG Pathshala. I am Dr. Rajiv Jain, Professor of Chemistry at Jivaji University, Gwalior. Today, I shall take up cleanliness and neatness in the laboratory under the paper Fundamentals of Analytical Chemistry. Here, learning objectives are how to maintain a neat laboratory, how to clean the laboratory, how to avoid spilling of the reagents on your working table, how to take care that no accident take place, how to maintain your clean sink, wash basins and shelves and your passages in the laboratory. So the objective of my lecture here today is very simple. As you keep your home clean, you keep your working table clean. Similarly, in the case of laboratory, where you have large number of chemicals, large number of reagents, large number of glasswares, that you have to maintain, you have to keep them at proper places. Reagents should be placed at proper places. The instruments, the glassware which are not in use should be placed in the shelves, in the cupboards, beneath your working bench. And on the working bench, only those glassware should be there which are in use. And here you will learn how to clean these glassware, how to calibrate these glassware, and how to maintain good laboratory practices. Neatness also includes stewardship over the more permanent laboratory fixtures such as ovens, hot plates, hoods, sinks, and the benches themselves. No analysis should ever be performed using anything but clean glassware. Glasswares that look clean may or may not be clean as an analyst understands the term. Surfaces on which no visible dirt appears are often still contaminated by a thin, invisible film of greasy material. When water is delivered from a vessel so contaminated, it does not drain uniformly from the glass surface, but leaves behind isolated drops that are troublesome or sometimes impossible to recover. Glassware into which a brush can be inserted, such as beakers or earthenware flasks, are best cleaned with soap or synthetic detergent. Pipettes, burettes, and volumetric flasks may require hot detergent solutions for thorough cleaning. If the glass surface still does not drain uniformly, it may be necessary to use cleaning solution whose strong oxidizing properties ensure clean glass surfaces in most cases. After cleaning, apparatus should be rinsed several times with tap water, then with small portions of distilled water, and finally allowed to drain. Cleaning solution is usually avoided in biological work because many microorganisms are sensitive to traces of chromium which remain on the glass even after thorough rinsing. It is well known common proverb that next to godliness is cleanliness. A chemical laboratory must maintain a high degree of neatness and cleanliness that may indirectly contribute as a major factor in laboratory safety. Passage ways either around the working benches or in between them should not be made untidy by litter. Rather, these are to be thrown into a metallic covered dustbin kept in one corner of the laboratory. The top of the working bench always be kept neat and tidy and avoid scattering with apparatus not in use. All such apparatus should be stored in the cupboard beneath the bench. Likewise, all dirty apparatus should be dipped in either a solution of detergent or a cleansing mixture in a plastic bowl a little away from the working area that may be cleaned and kept away for future uses as and when required. All solid and filter paper waste should not be thrown in the sink. It is the prime responsibility of a good chemist to meticulously and scrupulously clean and subsequently drying of all used glasswares. For highly moisture sensitive compounds, the glasswares need to be rinsed with acetone twice at least, dried in an oven and brought to ambient temperature in a desiccator. It is indeed advisable to clean up the used reaction flasks and other apparatus immediately after their uses so as to avoid tedious cleansing process later on. It is pertinent to mention here that there exists not a single known universal cleansing mixture. Therefore, based on the nature of the deposit and amount of the deposit, a chemist must undertake the process of cleaning accordingly in a systematic manner rather than adopting a haphazard style. The various usual standard cleansing processes are: number one, basic residues. Dilute sulfuric acid or hydrochloric acid may dissolve the basic residues completely. Number two, for acidic residues, dilute sodium hydroxide solution is probably the commonest and the best cleansing agent for most acidic residues. For organic solvent miscible residues, instances where the stubborn residues that are miscible only in comparatively cheaper solvents may be used profusely and should be collected in the residues bottles and not down the sink. The combined residual organic solvent may be distilled off to recover the good solvent and reject the heavily contaminated material appropriately. Number 4. Gross deposits. The cheapest, best and simplest means to get rid of gross deposits may be accomplished by employing commercial household washing powder containing an abrasive component that does not necessarily scratch the glass surface at all, such as Rin, Vim, Ajax, etc. The washing powder could be applied either directly into the apparatus previously moistened with water or using a test tube cleansing brush that has been soaked into the powder. The surface of the glass is subsequently scrubbed gently, followed by vigorously until the sticking dirt has been removed entirely. Ultimately, the glass apparatus is washed and rinsed thoroughly with soft tap water. So far, you have learned how to clean, how to remove impurities, maybe organic or inorganic, adhered to your glassware, how to remove your impurities deposited on a beaker, on a conical flask, in a pipette, on a burette by using different types of solvents. But in some cases, it is a stubborn impurities which are there at the burette or in the conical flask or on the funnel. Then you have to apply some chemical mixture, and most commonly used from decades, from very early ages, most commonly used reagent for that purpose is chromic acid. That chromic acid is prepared by taking reagent sodium chromate or potassium chromate, then dissolving in it water and then adding in sulfuric acid. For example, For preparing a solution of sodium chromate, you can take about 5 grams of potassium chromate, dissolve in 5 ml of water and add to it 100 ml of sulfuric acid. It will give you a very strong chromic acid reagent. By this reagent, you add it to your one flask, one conical flask, one beaker, then transfer the same to another one. Like that, in a chain, you may wash, you may rinse your glassware with this chromic acid reagent. That glassware which is not been cleaned to your satisfaction. If you want to clean the glassware to your satisfaction, which is still having droplet attached to that glassware, that can be removed by using this very stringent and strong oxidizing agent, chromic acid. After treating the glassware with chromic acid, you should wash it repeatedly with tap water. When tap water, and you should see that not a single drop should adhere on the glassware, and after washing it, remove all the water, drain out all the water from the glassware, then keep it in the oven. Importantly, in case the above cited 4 cleansing methods do not offer 100% satisfaction, one may attempt stringent alternative cleansing solution, namely chromic acid cleansing solution. The glass apparatus to be cleaned must be rinsed with water to get rid of water-soluble organic matter as far as possible, along with the possible reducing agents, if any. Subsequently, the water is drained off from the apparatus to its maximum extent, and the chromic acid cleaning mixture is introduced into it in a quantity just sufficient to smear the solid residue completely, while the main quantum of the cleaning mixture is returned to the stock bottle. The cleaning mixture treated apparatus is allowed to stand for about 15 to 20 minutes, with occasional swirling of the apparatus to stretch out the liquid onto the surface of the solid residue. The apparatus is then rinsed thoroughly with running tap water and finally with distilled water. Whereas the use of ultrasonic energy to clean objects, including medical and surgical instruments, is a very common practice in a hospital environment. Importantly, such sophisticated techniques have also been exploited from a highly sensitive sterile zone of an operation theater in a hospital to the chemical laboratory for the benefit of research chemists as well. The ultimate and final removal of trace residues from previously treated and cleaned glass apparatus may be accomplished by ultrasonic bath. It is important to know that all apparatus essentially loaded with gross impurities must not be cleaned in these high-tech baths for obvious reasons, because the tank fluid shall become contaminated, thereby minimizing its overall efficiency to a significant extent. One of the major and most crucial functional utilities of ultrasonic bath is their excellent and remarkable ability to loosen difficult and rather stubborn ground glass joints when they get fused on account of degraded chemical contaminants or a prolonged neglect by the user. Drying of cleaned laboratory glasswares. There are two different sizes of glass apparatus. One invariably comes across in a chemical laboratory. For instance, small glass apparatus and large and bulky glass apparatus. Small glass apparatus. These are thoroughly cleaned and rinsed with distilled water and kept in an electrically heated oven, preferably having an inside chamber and trays made up of stainless steel previously maintained at 100 to 120 degrees centigrade for a duration of 60 minutes. Large and bulky apparatus. There are really large and bulky apparatus which fail to enter an oven for drying or sometimes are needed soon after washing for urgent experimental operations. Therefore, other viable, effective, and convenient means of drying, such as large and bulky apparatus, have been devised duly, such as in case the apparatus is wet with water, the latter is removed to the maximum extent and subsequently reached with a small quantity of either acetone or industrial spirit. The final drying is done with the help of hot air blower, and this hot air blower is very useful for large size glass blower. Now, when your apparatus, glass apparatus has been cleaned to your satisfaction, now the turn is for calibration. So there are methods for calibration of glassware. The first method, which is designated as direct absolute calibration, is based on the principle which is based upon the fact that the volume of water delivered by a burette or pipette or contained in a volumetric flask is obtained directly from the weight of the water and its density. Volumetric glassware is sometimes calibrated by comparison with another vessel previously calibrated directly. It may be referred to as indirect absolute calibration or calibration by comparison. This method is especially convenient if many pieces of glassware are to be calibrated and it is sufficiently accurate for all ordinary uses provided the reference vessel itself has been accurately calibrated. Calibrating bulbs are not available in many student laboratories and specific directions for their use are not included in this lecture. They are not difficult to use if proper care is taken. The students, you may obtain direction for the use of this type of bulb from your laboratory technician or supervisor. Sometimes it is necessary to know only the relationship between two items of the glassware without knowing the absolute volume of either one. This situation arises, for example, in taking an aliquot portion of a solution. Suppose that it is desired to titrate 1/5 of an unknown solution. The unknown might be dissolved, appropriately treated, preparatory to the titration, and diluted to volume in a 20 ml volumetric flask. A 50 ml pipette would then be used to withdraw an aliquot for titration. For the calculation in this analysis, it would not be necessary to know the exact volume of the flask or the pipette, but it would be required that the pipette hold exactly 1/5 as much solution as the flask. This method is known as relative calibration, and this is a very simple method of calibration. The next thing, and in the last, after cleaning the laboratory, maintaining the neatness in the laboratory, then calibrating your glassware, weight box, etc. Now recording the data which you have obtained after analysis. How to record a data in your practical notebook. There are three main requirements for the recording of data obtained in the analytical laboratory. These may be broadly divided into three classes. The record should be complete. Number two, should be intelligible to any reasonably competent chemist, and number 3 should be easy to find on short notice. The requirement may be met by adherence to the following rules. Rule number 1. The student should have a bound notebook for recording laboratory data, calculations, results, and other matters pertinent to the analysis of a sample. The pages of the notebook should be numbered and a table of content should be developed so that any experiment can be quickly found. Number 2. All data obtained in the laboratory should be recorded directly in the notebook at the time the work is performed. Not in the rough notebook, but directly recorded in the practical notebook. Especially forbidden is the recording of data on loose papers, with the idea of copying it into the notebook later. While the neatness may be sacrificed somewhat by taking the notebook directly into the laboratory, the prevention of loss of data and errors in transcribing them more than counterbalances this. Entries in the notebook should be recorded in ink. If a mistake is made and a recorded value is invalidated, it is not to be erased but is crossed out so as to still legible. A notation as to why it has been rejected is made in the notebook. Next point, the data in the notebook should be organized and recorded in a systematic way. This benefits the students because it is then relatively easy to locate errors in the analytical calculations. The student may thus be saved repeating an entire determination in order to obtain satisfactory results. To facilitate an orderly presentation of the data, the student should plan how best to record it before the experiment is actually begun. It is especially helpful to arrange beforehand a table in which the experiment data, the calculations, and the final results can be entered systematically. Good laboratory practices may be defined as a body of rules, operating procedures, and practices established by a given organization that are considered to be mandatory with a view to ensuring quality and corrections in the results produced by a laboratory. They all contain two common elements: standard operation procedures and a quality assurance unit. Standard operating procedures provide detailed descriptions of activities performed by the laboratory. Example, Examples are sample custody chain, sample handling and preparation, the analytical method, the instrument maintenance, archiving, and similarly many minute details to be meticulously recorded. Detailed sample analysis procedures are provided for laboratory analysis or technicians. These are generally more detailed than given in scientific publication of developed methods, since the level of training and experience of different laboratory personnel will vary. So, in this lecture, today you have learned a very important thing, that how to maintain neatness in the laboratory, how to clean the glassware. Because if your glassware is not clean, if some oxidizing agent is there, if a small particle is there, then it will destroy your whole the experiment. Error will be there. If you are going to do kinetic studies and a small particle of oxidizing agent is adhered at the glassware, then it will change the rate of your kinetic reaction. So for doing that, you have to wash, you have to clean the glassware by any means. And there are four methods which I have discussed with you, and then the treatment with very strong abrasive chromic acid reagent which is being used from very early days. Even if then your burettes and pipettes are not working well, because if you leave the pipette and burettes after use, you do not wash it, then something will deposit, some chemical will deposit, or in the case of glass joints, some chemical will deposit and glass joint will not be loosened in any case. As in the case of measuring flask, you put a stopper there with the help of a glass joint, stopper there, but that glass joint will not open if some chemical remains there. For that purpose, you have to apply ultrasonic energy there. Ultrasonic bath have to be used. You have to take ultrasonic bath means you are applying ultrasonic energy. You will put your all the joints there, all the glassware with joints. You will put in the ultrasonic bath, and it is the only method for loosening the joints, and by that treatment for hour or 2 hour or 3 hours, you will find that their joints are now released, they can be operated, and again you can use them. So this is the another method in case of if you are careless and if you have left your glassware uncleaned at the time of working, then you have to clean the glassware by using this ultrasonic energy. But it is recommended and it is desired that you should be very clear that immediately after working, after completing your experiment, you should wash the glassware thoroughly. And another important thing which I want to mention here, that you should record the data directly in your notebook. I have noted that students usually note the data on a loose paper or on a rough notebook, but that is not a good practice. Laboratory good practice is that you should note the data, you should note the you should record the data on your practical notebook, and for that purpose you should have already practical notebook pages in a tabular form. In that tabular form you will write the data directly. You need not to fear or afraid of that it may be mistake, error may be there, but do not worry for that. You, if data is different, you cut the recorded data and write again data, and data should be written such that earlier cut data should be clearly visible. And in the side, you may note the reasons why you have to cut the earlier reading and you have to mention new readings. So this type of recording of data comes under good laboratory practices, because after some time, after a year, after 6 months, when your record is checked, it will find that student is has very carefully, very meticulously recorded the data, and there is no manipulation of any type. So such type of practices should come in habit, and once habit is formed, then in any case you will follow good laboratory practices, and you will maintain neatness and cleanliness in your analytical laboratory. Thank you.